Hey, this is Presh Talwalkar. Here's a question that confuses many people. What is the square root of the square of negative 9? The answer choices are A, plus or minus 9, B, minus 9, C, 9, or D. Each answer is correct depending on context. I did a poll, and I'm thankful to all 64,000 of you who voted. And the results were pretty conclusive. 61% of people thought the answer was C, just 9. 22% of people said plus or minus 9. 13% of people said the answer depends on context. And 5% of people said minus 9. This is not just some theoretical question. This is a question that you might actually have in real life situations. It could be a question on an exam or a homework problem. You might also need to know how a calculator would evaluate this expression. You will also need to know how this expression is evaluated at work. You might be putting this into a spreadsheet. You might be putting this expression in Python or JavaScript, and you would need to know what this expression evaluates to. So in 99.9% of situations, what's the correct answer? There is just one answer, which is C. The square root of the square of negative 9 is only equal to 9. Let me provide two explanations to justify the answer. Let's go through it step by step. We first want to evaluate under this radical. So we have the square of negative 9, which is equal to negative 9 times negative 9. That's equal to 81. Now we need the principal square root of 81. For a real number x, the principal square root of x is always greater than or equal to 0. So what number multiplied by itself will be equal to 81? That will only be positive 9. That's one way to understand the answer. Here's another way. We have the identity that the square root of x squared is equal to the absolute value of x for real numbers x. In this case, x is equal to minus 9. The absolute value of x is equal to positive 9. Therefore, the square root of the square of minus 9 is equal to positive 9. Now, I just want to illustrate that this answer is true in the real world. You can input this expression into Wolfram Alpha, any scientific calculator, or you could even put it in a programming language like Python. The result will always be a single answer, which is positive 9. But one thing I've learned as a YouTuber is that just showing people calculator results or even programming results is not always convincing. So people want to understand a more general point. Why is this convention the case? Why do we have a single value and why is it just positive 9? So where does all the confusion start? Let's go back to solving an equation x squared is equal to 81. What are the solutions to this equation? There are two solutions. X equals 9 is a solution because 9 squared is equal to 81. But we also have x is equal to minus 9 as a solution because the square of minus 9 is also equal to 81. So if x squared equals 81 has two solutions, that x is equal to 9 or minus 9, one might be tempted to think the principal square root of 81 is equal to both plus or minus 9. But why is this not the convention? Why are we saying there's only one value? Let's think about it graphically. If we want to graph the function y is equal to x squared, we get a nice parabola. For every single y value, there are two corresponding x values. Now let's imagine we want to invert this function. So the normal way we could invert a function is we could reflect the graph about the line y is equal to x. So we would end up with this parabola that's facing to the right. So this could be considered the inverse function. But let's examine this function. Could it possibly be a single-valued inverse function? Well, a single-valued function would have to pass the vertical line test, which means every single input x would only give one value y. But this green graph does not pass the vertical line test. If we say that the square root of 81 is equal to plus and minus 9, then this green graph will not be the graph of a single valued function. So we somehow need to fix this. You could think about a tree that has overgrown all of its branches. What do? If you want to have the tree in a perfect shape, you might actually prune the tree down so that you get rid of some of the branches and you're left with only one branch. So somehow we have this parabola with multiple branches and we want to prune it down so that we can modify it into something that is a single valued function. So let's just get rid of this bottom branch and we are left with just one branch of this parabola. And now we actually will have a single valued function. If we say f of x is equal to the principal square root of x, we have a single valued function. So the principal square root will be where the result is non-negative. It's greater than or equal to 0. So the square root of 81 only has one value, which is positive 9. So when you have an input that's a positive number, if we take the square root of that number squared, we will undo the squaring process and end up with the original number. But if the original number was a negative number, we end up with the opposite result. If the original number was 0, then the square root of 0 squared is equal to 0. So summarizing all of these cases, we end up with the rule that the square root of x squared is equal to the absolute value of x. So in order to get the square root to be a single valued function, we need to consider the principal square root, and that will only return one value for real numbers. We want a single valued function because that's what we're used to. We've studied these extensively with continuous functions or differentiable functions. It's important to have single valued functions. And this is what you're going to deal with 99.9% of the time. But there is an exception to the rule. If you browse Wikipedia, you might come across multi-valued functions. What's the motivation? It comes up in complex analysis. And if you skim further down in the article, there is an example given that every real number greater than 0 has two real square roots. So that square root may be considered a multi-valued function. For example, we may write the square root of 4 is equal to plus or minus 2, which is two values, although 0 only has one square root. The square root of 0 is equal to 0. I will admit reading this article surprised me, and I was wondering how much of a convention is this actually? Well, it turns out other mathematicians were surprised too. This article ended up as a discussion on the forum MathStack Exchange. Someone was asking how common is it to have the square root as a multi-valued function? And the answer was the standard convention is that the principal square root of x will be the non-negative solution to the equation y squared is equal to x. So we have a well-defined function. So it is actually a standard convention that the square root of x will be a non-negative value. And in this particular answer of multi-valued functions, it is an exception to the rule. It's not a conventional thing. So if you are studied complex analysis and the square root is a multi-valued function, this is something that would be spelled out very clearly. It's not just going to come out of nowhere that you're going to want two values to a square root. Just to illustrate the point one more way, let's consider a general quadratic equation, ax squared plus bx plus c is equal to 0. What's the general solution? Everyone at some point has memorized the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Notice we have a plus or minus the square root. If the square root of 81 was equal to both plus and minus 9, there would be no need to put the plus or minus here. It would already be included in the square root. If you are going to argue that the square root of 81 is equal to plus or minus 9, I want you to write the quadratic formula just as a single plus. But like the rest of us, if you're going to put a plus or minus here, then I think it would be fair to say the square root will just have one value. So in this case, the square root of 81 is equal to positive 9, and therefore the square root of the square of negative 9 is a single value 9. And that's the answer. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.